The Go standard library has a bunch of testing features baked into it, which is awesome. So let's go over it. Let's start with some basic unit tests using the testing package. So here we have a math.go file with a couple super simple functions that we're going to test. The actual testing code needs to go in a new file, so we'll create a math_test.go. The test file must have _test at the end of the name. And if you want to test unexported functions in your package, then the test file needs to be in the same package as the actual code. But if you want to run your test treating the package you're testing like a black box with only access to the exported functionality, then in your package name in the test file, you can append tests to the end. You can also put your tests in a separate package entirely, which also limits you to the exported functionality. And that's super common for integration tests or end-to-end tests that test multiple packages. Okay, let's get to some actual testing code. You need to create a testing function for each test you want to run. And we'll start with this super simple one for testing the add function. Now the function name must start with test, and it's convention to append the name of the function you're testing to the name. But you could literally put anything here and it would still work. Testing.t is the main type that you'll be working with from the testing package. It has a bunch of functions that you can use to control the test, and I'll go over most of them here, but I'll link the docs in the description if you want to check out the rest. So super basic test. First, we're going to call our function and get the result out. And then we just need to check the result. And if the result is wrong, we're going to use the t instance to fail the test. And the t type has a bunch of methods you can use to fail your tests. Other than t.fail, there's t.error, which lets you pass arguments into it, and we'll log those arguments. Then there's t.errorf, which lets you pass in a formatted string to log, and you'll probably be using errorf the most if you want expressive tests. So these three methods fail the test, but don't stop test execution. So if you have more tests in this same function, which I'll go over in a bit, then those will continue to run. But there's another three methods that fail the test and immediately stop the test execution. So t.failNow fails the test, stops execution. T.fatal is like error, and it lets you log outputs. And then t.fatalf is like errorf, and lets you log an output string. So these three are useful when continuing down the test would cause a panic or something. So let's comment these out. And one other important point to mention is that you need to test using if statements in Go. There's no native support for assertions. So you can't do something like expect got.to-be 5. And I'm personally fine with using if statements, especially now that AI can power through my tests. But if you really want assertion support, you can use something like the third-party Testify package, which I'll leave a link to in the description. So that's the most basic single test you could possibly write. But if you want to test a function multiple times with different cases, you need to set up subtests. So I'll add another testing function to show you how that works. So inside, first you would run any code that you need to set up for the multiple tests you're going to do. And then you're going to call t.run for each test that you want to do. So we'll give the test a name, and that will be printed out so you can see which tests are failing. And then it takes a nested testing function that also accepts testing.t, and you'll write your tests here. So I'll just add the same case that we did before. Call errorf if it fails. And then we can add as many of these as we want. But if you have too many subtests, your code can start to get pretty complex. So the best practice is to use table-driven tests. And that concept is pretty simple. Basically just define your inputs and expected outputs in a map or slice, and then range over those to run each test. And the Go Wiki has a good article on this, so I'll link that in the description. So let's make another testing function to demonstrate. And we'll test the max function this time. So I'm going to create a slice of structs that will represent our tests. And it's an anonymous struct, so we'll define the fields here. So the name of the test, values to pass into the max function, and the value that we want out. And then you can populate the slice with different test cases. So we'll have one where the first number is larger. We'll do one where the second number is larger, one where the numbers are equal, and one using negative numbers. Then to run each test, we're going to do a for range loop over the tests. And for each one, we're going to use t.run, give it the test name, have our testing function, and do our test. So we'll call max, test.a, test.b, and do the check. And fail the test if we don't get what we want. Now, as we all know, Go's strength is running asynchronous workloads, and testing is no different. But by default, all of your tests are going to run sequentially, unless you mark them as parallel. And it's super easy to do. You just call t.parallel at the top of your test. Now, when you run your tests, Go will run all the non-parallel tests sequentially. And then after all that's done, it'll run the parallel tests all at once. Okay, next, if you need to do a global setup and teardown for all of the tests that you're running, then you can use the test main function, which takes in an M instance from the testing package. So this will execute before your tests are run. Then in the function, we can do whatever setup we need. And for the teardown, we're going to defer doing the teardown until the end of testing. And to actually run the tests, you still need to call m.run. And I'll just add some blank functions here so this works. Super easy. So let's run these tests. And if you're in the directory of the package you want to test, you just do go test dot, and we get the tests. But if you're in the root directory of your project, you can run go test dot slash dot dot dot, and that will recursively test everything. Then there are a bunch of flags you can use with the go test command that will control the tests and the output. And I'll just go over the basic ones now. So go test -v will give you verbose output, and you'll use this most of the time because if you noticed before, not super useful, much more useful. Then the race flag will tell you if any race conditions are detected. The shuffle flag will let you randomize the order the tests are run in each time you run your tests. And there are a bunch more, and you can see all of the flags using go help test flag, and it'll give you output of all the flags you can use with the go test command. Okay, next you need to know how to categorize tests. And it's basically labeling them so you can run certain groups of tests at once and skip other ones. So the first way is using build tags at the top of your file. So you do comment go:"build, and then label your test group. Now, if we run our tests normally, Go will skip any of the test files that have a build tag. But now we can run go test with the tags flag to isolate the tests that we want. So this will test only files labeled as unit tests. This is my preferred way to categorize tests, but the drawback is that you don't get any notifications about what tests were actually skipped. And if that's an issue for you, then you can use environment variables instead and manually skip the tests. So you can do os.get env. Let's go unit. It's not equal to true. Then we're going to skip this test using another method on the t type, t.skip, and pass a message. Pretty straightforward. Okay, the last thing you need to know about for categorizing tests is using short mode. And you turn short mode on by using the -short command. And all this actually does is set a package level variable on the testing package that you can access through a function they give you. So let's say we have a long running test. And we want to skip this test if we're running in short mode. So we can check if testing.short, then we're going to do skip. So my projects aren't really large enough for it to be worth doing any of this categorization stuff. But if you're working on large projects, then it's definitely useful to know. All right, short section of the video now, mostly just an aside. If you need testing data in files, then you should put it in a test data folder. And Go will ignore anything inside a test data folder, but you can pull stuff out during your tests. And next up, we're covering test coverage. And Go has direct support for this, which is pretty cool. So if you just want the coverage reported in the terminal output when you're testing, you can just use the -cover flag and do your testing normally. And then we get the coverage out. And if you want to save the coverage to a file, then you can use the cover profile flag and pass in the file name. And it's convention to use .out as the file extension, but you can use whatever you want. Now, by default, Go will only calculate the coverage for each package using the tests that run inside those packages. But if you have integration tests outside of your packages that touch multiple packages, you can specify that you want coverage for those packages using the cover package flag. So let's say I have an integration test folder. If I wanted coverage for my math package while I'm testing from integration, then I can add the cover package flag and pass in the path to the math package. So we created a coverage.out file, but if you want to actually see useful information, you can run go tool cover and pass in -html and link to your out file. So this creates an HTML file that will highlight what code has been touched. All right, let's talk mocking, aka reason number 365 to start using interfaces. So for simple mocks, the best way is to design your code using interfaces with dependency injection. Then you can swap out a mock version of an interface whenever you need to. So for example, if we had a welcome function that's responsible for sending a welcome email to an address, you wouldn't want to test this normally because you don't want to be sending emails all the time. So we should design it ahead of time for testability. First, we'll have an interface called sender. And it will have a single method that's responsible for sending the email. And now when we call the welcome function, we're going to use parameter injection and pass in the sender. Now inside the welcome function, we're going to call s.send, pass the address and our welcome message. And if we have an error, we'll wrap it up and return it. Otherwise, we'll return nil. And this design is awesome for testing because now we can build out a mock sender type with a dummy send function. Now, the tricky part here is that we need state on our mock that will actually be useful when we're testing. So say we wanted to make sure we don't call send more than once, then we need a call count field. And then in our send method, we'll increment it. And then if I want to make sure the email is sent to the right address, add a sent to field. And again, set that in the mock method. Now in the actual test function, I will create a mock sender, call welcome, pass in our mock sender, and then check the fields on our sender to do the actual testing. So if this is not equal to 1, we'll log that it should be equal to 1. Then if we sent to the wrong address, we'll log that too. So this whole setup is great for simple stuff, but if you're implementing call counts and logic over and over again, then a third-party mocking package can help. I personally don't think it's typically necessary now that AI can just generate it all, but you can use something like Uber's mock package, which will generate hard mock implementations of your interface types and give you pre-built behavior checks that let you do things like check how many times a method was called. And that is all the basics of testing in Go, but there's still a bunch of stuff I didn't cover. The testing package has support for benchmarking and fuzz testing. There's the HTTP test package, which lets you test Go native net HTTP code, and the sync test package for testing async code, and a bunch more. I'll make videos on those in the future, so hit the bell if you want to be notified. Thanks for watching, and as always, keep breathing, keep building, and I'll see you next time. Peace out.